Hi, in this occasion we are going to solve a problem about free fall. The problem says you are on the roof of the physics building, 46.0 meters above the ground. Your physics professor, who is 1.80 meters tall, is walking alongside the building at a constant speed of 1.20 meters per second. If you wish to drop an egg on your professor's head, where should the professors be when you release the egg? Assume that the egg is in free fall. Okay guys, at first we have to find the distance the professor walks during the time t that takes the egg to fall to the height of his head. Um, in order to do that, let's set the origin of coordinates at the top of the building. So what we do here is we set the origin of coordinates on top, okay, on the top of the building, right here where I am writing the origin of coordinates. So the horizontal would be the x-axis and the vertical would be the y-axis. We are gonna take because we are taking the origin of coordinates just on top from the at the point where the egg is releases. The movement of the egg downwards is gonna be taken as positive, right? Because we are taking the origin at this point. Otherwise, if we take the origin on the bottom of the building, we have to take the movement. We have to take this axis of negative, this axis downwards. But because we are taking the origin just on top, we take it as positive. Because you are dropping the egg from the rest, the egg has no initial velocity, so we take initial velocity as 0. Okay, from the problem we know that y is the initial height, the initial position where the egg is released from, and it is 46.0 meters, or that is the building height. The professor height is y0, right? We are taking that position as y0 and is 1.80 meters. All right. Here, what we can do here is, if the egg is releases from the top of the building, from the 46.0 meters height at this point, you are here releasing this egg. This is y, this distance is y, okay. The professor is walking alongside to the building, but his height is y0. So what happened when the professor is just below the point where you drop the egg? Okay, this distance, the difference between y and y0 is gonna be y minus y0, and that's the distance the egg has fallen to hit the professor's head. All right, at this point the egg is hitting the professor's head. So this is the distance that the egg has moved, all this distance, all right, all this way down. That's y minus y0, okay. So we remember that y is 46.0 meters. And we remember that y0 is y.80 meters. So we can calculate the difference between these two balls as 46.0 meters minus 1.80 meters. That's it. 44.2 meters. That's the distance the egg has to fall to hit the professor's head. Alright. We can use a formula from free fall motion to study this problem. The formula is this: y, if you remember it, is y minus y0 is v0 multiplying the time plus 1/2 of the gravity multiplying the time squared. Okay. Sometimes this formula has this sign as negative, but when does that happen? Okay, that happens when that depends of the origin of coordinate. That depends where we take the origin of coordinates. If we take the origin or coordinates on top, right here, we use the positive sign. But if we take the origin of coordinates on the bottom instead of the top, we have to use the minus sign. But because in this situation we are using or we are choosing the origin of coordinates on top, what we have to take or what we can do is use the sign, positive sign. Alright? So that's why we are taking this sign as positive instead of negative. If you remember pretty much what is the vol of the gravity, of the acceleration of the gravity, that is gonna be 9.80 meters per second squared. Alright, and this equation that I am using here is the position as a function of the time for an object moving with free fall. So that's the formula we can use. The position as a function of the time for an object that is moving with free fall. Okay, you should remember that the velocity, initial velocity, is 0. Okay, why the initial velocity of the egg is 0? Well, it is 0 because you drop the egg from the rest, right? So because you drop it, you release it from the rest. That means that its initial velocity is 0. And because the initial velocity is 0, we can go to the principal equation that we are using here, and we can take that term as 0. And because we can take that term as 0, we are gonna have y minus y0 is equal to 1/2 of the gravity time squared. Okay, now what we can do is this: we can take these two, that is dividing on this side of the equation, and we take, before that we put y minus y0 into parentheses, and we take these two that is dividing to multiply on this side, right? And the same we do with the gravity. the gravity is multiplying on this side. We take it to, we move it to this side, but to divide. And when we do that, we get 2 dividing the gravity, multiplying the difference between y minus y0 equal to the time square. We want to, what we are doing, okay, we want to calculate the time that the egg takes to fall the distance y minus y0. Okay, this distance we are calculating the time the egg takes to fall that distance all the way down. And we, in order to do that, we have to clear the time, okay, to calculate this quantity. Okay, well, we take root square on both sides of the equation, and this root square eliminates with this square as well, and we have root square of 2 dividing the gravity, multiplying y minus y0, and that is equal to the time. The next step is replacing the numerical quantities into the equation. Right. If we remember, y minus y0 is 44.6. 44.2, sorry, 44.2 meters, and the gravity is 9.80 meters per second square. Okay, we replace these terms into the equation, and we have t equal to the root square of 2 dividing 9.80 meters per second square, multiplying y minus y0, but y minus y0 is 44.2 meters. And that's it, 3.0 seconds. That's the time the egg takes to fall. That's the time the egg takes to fall and hit the professor's head. Okay? So, that's the time that the egg takes to fall 44.2 meters, that distance. Okay, keep continuing doing this. What distance the professors walk? What is the distance that he walks? Right. He is walking with a constant speed. If you remember, he's walking with a constant speed, and the problem says that he's walking with a constant speed of 1.20 meters per second. That's the velocity. At that velocity, the professor is walking. Okay? So, we come back here and we say he's walking at this velocity, 1.20 meters per second, right? The time, we have to be careful here because he starts walking from this. Let me do something here. He starts walking from this point, right? And the time it takes, and the time that he takes to walk from this point where he is at first to this point where the egg hits his head, he has to walk this way and this distance d. So the time that the professor takes to walk the distance d is the same time that the egg takes to go from this point to this point, right? I'm gonna repeat it. The time that the professor takes to walk the distance d here, the distance d, the time that the professor takes to walk the distance d is the same time that the egg takes to go y minus y0 distance. Okay, this distance. Right? So that's the same time. Okay. Because that is the same time, we know that the time is 3. We calculated the time, right? Earlier is 3.00 seconds. Okay? And because he is moving at constant speed, we use the formula for constant speed, right? The distance is velocity times the time. And if we use this formula to calculate the distance d, we are gonna get d is equal velocity 1.20 meters per second multiplying 3.00 seconds. And because this second is on the bottom and this is on top, they eliminate each other, and the result is gonna be done in meters, and this multiplication is 3.6 meters. So that's the distance d that he walks. Well, this is the distance that he has to be at first from the bottom of the building to get hit by the egg. Otherwise, if he is at a different point, the egg won't hit his head. So this is the, I'm gonna repeat it, this is the distance. It has to be a first, that way the egg can hit his head. Okay guys, this is all for today. Hopefully this problem helped you to understand some physics. Don't forget to subscribe to this channel, to give me a like, and see you next time. Bye.